All right, so this will be a quick video. We're just going to look at common mathematical relationships. All right. And in physics, okay? And the first kind is straight up, it's just linear. So that's where the data just comes to you in some sort of straight line form, right? That or something along those lines, okay? And you can have this as well, okay? You have like a negative relationships. And we would put that under the kind of heading of y is somehow proportional to x. Okay, so as x gets bigger, so does y, but it happens in a linear fashion. All right, this is the kind you're used to, described usually as a y equals mx plus b. Sometimes b is 0, so you might not see it there, but that's the general form for this one. Very common, pretty standard. Okay, then from there, usually you start to learn about exponential relationships. You know, this is often taught with velocity and distance, right? So distance usually is velocity in time, but if you're now accelerating, you get into something that looks a little bit more like that. So exponential graphs generally have a curved shape to them. So, well, they always have a curved shape. So this is now where you're getting this kind of a thing going on, okay? Sometimes they're negative, okay, but there's a curve. So this is a graph with this type of a form. Y is proportional to x to the n, okay, to the power of n. N being 2, 3, whatever, okay? And you get an equation that looks like y equals mx n plus b. So the x value has an exponent attached to it. Make sense? So this is like an acceleration, a distance time graph for an accelerating object, or like a dropped object, an object that's fallen. So we have that. You might have an inverse relationship. Okay, so an inverse relationship shows a graph of this general shape, usually asymptotal. Usually it is asymptotal. Okay, so I don't know if you've come across these in math class yet or not, but these are the form y is proportional to some value over x. So often it'll just look like that, which just comes from this. Okay, so their equations are usually something like that. These are the kind of the most common ones in physics. And there's also the inverse square, which is like a subheading of the inverse, very common in physics. And it looks similar to this, right? It just depends on how you have your axes set up. It's kind of hard to tell if it's an inverse or an inverse square just by looking at it, unless you map the axes identically, which you often wouldn't do. So that's also going to look like this. Okay, so the ones that are of this form, where y is proportional to 1 over x to the n, look very similar to ones that are just y is proportional to 1 over x, but now you have a square in there. You know, so y equals m over x squared, cubed, whatever, n plus b. Okay, so that's a pretty common scenario in physics. And that's like related to the geometry of 3D space, and we'll get there when we get there. And there's a few more like kind of less, maybe more common or less common. Less common in physics, sometimes more common maybe in biology. You might find a square root one. Okay. This doesn't have to be a square root. It could be like a cubed root too, or some higher order root value. And those generally look kind of like this. Okay, so they trail off. So that kind of a thing. Okay, and you might even have some n value there. Okay, and I'll just mention it, but you likely won't see it. You might also have logarithmic relationships. Okay, so we don't need to go there today, but it's important that you can recognize these because you're going to get raw data, and when you graph it, it's going to look either linear, exponential, inverse, or square root. And when you're trying to figure out what the equation is to describe it, when you're trying to get this value, or actual values for this, you have to have the wherewithal to recognize what type of graph it is and what type of relationship is going to come out of it. Okay, so we're going to get to the actual nuts and bolts of how it would take something like this and figure out from data, from the chart, and from a table of data points, what the relationship between those two pieces of variable are. Okay.